Good day everyone. So today we are going to discuss about parabola. So first, let's define what is a parabola. So a parabola is the set of all points in the plane equidistant from a fixed point F and a fixed line L not containing F. So from the definition, let's say F is the fixed point and L is the fixed line. So if we try to get all points equidistant from F, so if we are going to get all points equidistant from F and L not containing F, then we can form a parabola. So let's move to the parts of the parabola. So we have axis of symmetry, focus, vertex, directrix, focal distance, and latus rectum. The line through the focus F that is perpendicular to the line of directrix is what we call the axis of symmetry. The axis of symmetry divides the parabola into two parts, and these two parts are what we call the mirror images. There is only one point on the parabola that lies on the axis of symmetry, and that is the vertex of the parabola. From the definition of the parabola, we all know that the vertex of the parabola is equidistant to the focus and to the line of directrix. So therefore, this distance and this distance is equal. The distance of the vertex to the line of directrix and to the focus is what we call the focal distance. From other references or other books, they denote focal distance as C or P. But in this module, we are going to denote focal distance as A. The latus rectum is the segment through F and endpoint of the parabola. So therefore, the latus rectum is the segment containing F, which is the focus of the parabola, with endpoints of the parabola, and it is perpendicular to the axis of symmetry. The total distance or the length of the latus rectum is 4a. So therefore, from the focus to one endpoint is 2a. And from focus again to another endpoint is 2a. So these two will sum up to 4a. So therefore, the total length of latus rectum is 4a. Next, we have the standard form of the equation of the parabola with vertex at the origin. There are four equations we should remember with the standard form of the equation of the parabola with vertex of the origin. We have y squared is equal to 4ax, y squared is equal to negative 4ax, x squared is equal to 4ay, x squared is equal to negative 4ay. So these four equations determine if the parabola opens to the right, to the left, upward, and downward. So how are we going to determine if the parabola opens to the right, to the left, upward, and downward? As you notice, if y variable is being squared, then it is either opens to the right or opens to the left. On the other hand, if the x variable is being squared, then it is either opens upward or downward. So we focus first on the equation y squared is equal to 4ax and y squared is equal to negative 4ax. So as I said, if the y variable is being squared, then it is either opens to the left and opens to the right. And how are we going to determine if the parabola opens to the right and opens to the left? If we have positive 4a, then it is opens to the right. But if we have negative 4a, then we have a parabola that opens to the left. As you notice, the focus of the parabola that opens to the right and left has y as 0. So the y-axis of the parabola that opens to the right is 0. So the focus of the parabola that opens to the right is a, 0, while the focus of the parabola that opens to the left is negative a, 0. From the definition of the parabola, we all know that the focus and the directrix is opposite to each other. So therefore, the directrix of the parabola that opens to the right is equal to negative a, while the directrix of the parabola that opens to the left is x is equal to a. And the axis of symmetry of the parabola that opens to the right and to the left is both y is equal to 0. On the other hand, if x variable is being squared, then the parabola is either opens to the upward or downward. So if we have positive 4a here, then the parabola opens upward. But if we have negative 4a here, then the parabola opens downward. So as you notice, the parabola that opens upward or downward has a focus of x as being 0. So the parabola that opens upward has focus of 0, a. And the parabola that opens downward has a focus of a, negative a. While the directrix of the parabola that opens upward or downward has y is equal to negative a for upward and y is equal to a for downward, while the axis of symmetry is both x is equal to 0. Let's have our first example. Determine the coordinates of the vertex, axis of symmetry, focal distance, length of latus rectum, and endpoints of the latus rectum of the parabola. X squared is equal to negative 12y. So we have here x squared is equal to negative 12y. We all know that if the variable x is being squared, then the parabola either opens upward or downward. But since we have here negative 12y, then the parabola opens downward. So in order for us to get the vertex, axis of symmetry, latus rectum, and the endpoints of the latus rectum of the parabola, we need to get first the focal distance A. So since the parabola opens downward, then we have x squared is equal to negative 4a. So in order for us to get the focal distance A, we are going to equate negative 12 to negative 4a. So we have negative 4a is equal to negative 12. So we are going to multiply both sides with negative 1/4. Then we have A is equal to 3. So the focal distance of the parabola, of the vertex of the parabola to the focus and to the distance to the line of directrix is 3. So we have 3 as the focal distance. So from the table above, the focus of the parabola that opens up downward is 0, negative a. So the focus of the parabola that opens downward is 0, negative a. So therefore, the focus of the parabola is 0, negative 3. From the table above, the directrix of the parabola that opens downward is y is equal to a. So therefore, the line of directrix of the parabola is y is equal to 3. And the axis of symmetry is x is equal to 0. So the last one we are going to get is the endpoints of the latus rectum of the parabola. We all know that the length of latus rectum of the parabola is equal to 4a. And from the focus of the parabola to the endpoint of the parabola of the latus rectum is 2a. So in order for us to get the endpoint of the latus rectum of the parabola, we need to get the 2a or twice the focal distance. So we have here 2a is equal to 2 times 3, then we have 6. Note that if we are going to get the endpoint of latus rectum of the parabola, we need to add the 6 to the x variable of the focus. So we have 0 plus 2a, negative a, then we have 0 minus 2a, negative a. So the endpoints of latus rectum of the parabola is 0 plus 6, negative 3, then we have 0 minus 6, negative 3. So the endpoints of the latus rectum of the parabola is 6, negative 3 and negative 6, negative 3. So the focus of this parabola is 0, negative 3. The directrix is y is equal to 3. The axis of symmetry is 0. the length of the latus rectum is 4a, which is equal to 4 times 3, that is 12. And the endpoints of the latus rectum is 6, negative 3 and negative 6, negative 3. So now, let's sketch the graph. So we all know that the vertex is at origin or 0, 0. So from what we have solved, the focus is at 0, negative 3. So we have 0, negative 3. And then the line of directrix is y is equal to 3. So we have the line of directrix as y is equal to 3. And then the axis of symmetry is x is equal to 0. So the axis of symmetry is this line. And then the endpoints of the latus rectum is 6, negative 3 and negative 6, negative 3. So we have 6, negative 3 and negative 6, negative 3. So let's just connect the vertex and one endpoint. So that is this sketch of the parabola with an equation of x squared is equal to negative 12y. We know that if the parabola opens to the right, the focus is a, 0. So therefore, the focus of this parabola is 2, 0. The directrix of the parabola that opens to the right is x equal to negative a. So therefore, the directrix or the line of the directrix of this parabola is x is equal to negative 2. And the axis of symmetry of this parabola is y is equal to 0. For the latus rectum of the parabola, the length of latus rectum of the parabola is equal to 4a. So the length of the latus rectum of this parabola is 4 times 2 is equal to 8. For us to get the endpoints of the latus rectum of this parabola, we need to get the value of 2a. So we have 2 times 2 is equal to 4. So the endpoints of the latus rectum of the parabola that opens to the right is a, 0 plus 2a. Then we have a, 0 minus 2a. So the endpoints of this latus rectum of the parabola is a, 0, 0 plus 4, and then we have a, 0 minus 4. So the endpoints of the latus rectum of this parabola is 2, 4 and 2, comma, negative 4. So these are the latus rectum, the endpoints of the latus rectum. Next, we are going to graph the parabola. So we all know that the vertex of the parabola is at the origin, or that is 0, 0. And the focus of the parabola is 2, 0. So we have 2, 0, and that is the focus. And then the line of directrix is x is equal to negative 2. So we have x is equal to negative 2. And then the axis of symmetry is y is equal to 0. So this is axis of symmetry. And the endpoints of the latus rectum is 2, 4 and 2, negative 4. So we have here 2, 4 and 2, negative 4. So we are just going to connect the vertex and the latus rectum of the parabola. So this is now the sketch of the parabola that has an equation of y squared is equal to 8x. So next is the standard form of the equation of a parabola with vertex at hk. We have 4 equations here. Quantity x minus h squared is equal to 4a quantity y minus k. Quantity x minus h squared is equal to negative 4a y minus k. Quantity y minus k squared is equal to 4a x minus h. And quantity y minus k squared is equal to negative 4a x minus h. So these equations will determine if the parabola opens upward, downward, to the right, and to the left. We all know that if the parabola has an equation as x being squared, then the parabola either opens upward or downward. But if the variable y is being squared, then the parabola either opens to the right or to the left. So here, if the parabola has an equation of x minus h squared is equal to 4a y minus k, or x minus h squared is equal to negative 4a quantity y minus k, then it is either opens upward or downward. Since we have here positive 4a, then the parabola opens upward. But if we have negative 4a, then the parabola opens downward. The focus of the parabola that opens upward is x, is h, k plus a. And the focus of the parabola that opens downward is h, k minus a. The directrix of the parabola that opens upward is y is equal to k minus a. And the directrix of the parabola that opens downward is y is equal to k plus a. The endpoints of the latus rectum of the parabola that opens upward is h plus 2a, k plus a, h minus 2a, k plus a. The latus rectum, or the endpoints of the latus rectum of the parabola that opens downward is h plus 2a, k minus a, h minus 2a, comma, k minus a. The axis of symmetry of the parabola that opens upward and down or downward is both x is equal to h. On the other hand, if we have y variable as being squared, then the parabola either opens to the right or to the left. So, if we have positive 4a, then the parabola opens to the right. But if we have negative 4a, then the parabola opens to the left. The focus of the parabola that opens to the right is h plus a, comma, k. And the focus of the parabola that opens to the left is h minus a, comma, k. The directrix of the parabola that opens to the right is x is equal to h minus a, while the directrix of the parabola that opens to the left is x is equal to h plus k. The endpoints of the latus rectum of the parabola that opens to the right is h plus a is equal to k plus 2a and h plus a, comma, k minus 2a. And the endpoints of the latus rectum of the parabola that opens to the left is x minus a, comma, k plus 2a and h minus a, comma, k minus 2a. And the axis of symmetry of the parabola that either opens to the right and or to the left is y is equal to k. Let's have first example. Determine the vertex, focus, focal distance, length of latus rectum, endpoints of the latus rectum, and axis of symmetry of the parabola y minus 1 square is equal to 8 quantity x minus 4. Graph the parabola. So we have here y minus 1 square is equal to 8x minus 4. So, since the y variable is being squared, then the parabola either opens to the left or to the right. But since we have here positive 8, then the parabola opens to the right. In order for us to determine the parts of the parabola, we need first to get the value of the focal distance, or that is a. So we have here 4a is equal to 8. Then 1/4 is being multiplied to the left side and right side of the equation. So we have 1/4 times 4a is a, and then 8 times 1/4 is 2. Therefore, the focal distance of the parabola is equal to 2. Next, we are going to determine the vertex of the parabola. The vertex of the parabola is h, k. H here is being paired in x and k here is being paired in k. So we have here from the equation of the parabola that opens to the right is y minus k squared is equal to 4a x minus h. So from the equation of the parabola, the vertex of the parabola is 4, 1. So we get 4 here from the x minus 4 and 1 here from y minus 1. So we get the opposite sign of h and we get the opposite sign of k being paired here in x and y. So next, we are going to get the focus of the parabola. So the focus of the parabola that opens to the right is h plus a comma k. So we have here h 4 plus a, which is 2, comma k, which is 1. So therefore, the focus of the parabola is 6, comma 1. Next, the length of latus rectum. So the length of latus rectum is equal to 4a, or that is 4 times 2, which is our a, is equal to 8. Then we get the axis of symmetry of the parabola. So the axis of symmetry of the parabola that opens to the right is y is equal to k. So therefore, the axis of symmetry of the parabola is y is equal to k, or that is y, our k there is 1. So therefore, the axis of symmetry is y is equal to 1. For the endpoints of the parabola that opens to the right, we have here h plus a, comma k plus 2a, then h plus a, comma k minus 2a. So 2a here is being added and subtracted to k. So we need to get the value of 2a. So 2a is equal to 2 times 2, which is the value of a, then we have 4. So the end of the latus rectum of the parabola is h plus a, comma k plus 2a, and h plus a, comma k minus 2a. So our h plus a is 6, comma 1 minus 2a, which is 4. And then we have 6, comma 1 minus 4. So the endpoints of the latus rectum of the parabola is 6, comma 5 and 6, comma negative 3. So the focus is 6, comma 1 with a focal distance of 2. The length of latus rectum is 4a. The vertex is 4, comma 1. The length of latus rectum is 4. The endpoints of latus rectum is 6, comma 5 and 6, comma negative 3. And the axis of symmetry is y is equal to 1. So now we are going to graph the parabola. So first, we need to put the vertex. So our vertex is 4, comma 1. So we have here 4, 1. So this is the vertex of the parabola, 4, comma 1. And the focus of the parabola is 6, comma 1. So we have 6, comma 1. So this is the focus of the parabola. Then we have the line of directrix, which is so the line of directrix of the parabola that opens to the right is x is equal to h minus a. So our h is 4 and our a is 2. So we have 4 minus 2 is equal to 2. So the line of directrix of the parabola, of this parabola, is x is equal to 2. So x is equal to 2 is the line of directrix. So this is the line of directrix, which is x is equal to 2. Then the axis of symmetry is y is equal to 1. So this is the axis of symmetry of the parabola. And the endpoints of latus rectum is 6, 5 and 6, -3. So we have 6, 5 and 6, -3. So we are going to connect the vertex and the end of the latus rectum to complete the parabola. So this is now the sketch or the graph of the parabola. Our next example, determine the vertex, focus, focal distance, length of latus rectum, endpoints of latus rectum, and axis of symmetry of the parabola y squared minus 2y minus 12x minus 11 is equal to 0, and then graph the parabola. So first, we need to convert this general form or general equation of the parabola into a standard equation of the parabola. So we need to convert this into standard form. So as you notice, the y variable here is being squared. So therefore, the parabola is either opens to the right or opens to the left. So we have here y squared minus 2y minus 12x minus 11 is equal to 0. Then we are going to add the additive inverse of negative 12x and negative 11 to the right side and left side of the equation. So we have here y squared minus 2y minus 12x plus the additive inverse of negative 12x is negative 12x is 12x, and then the additive inverse of negative 11 is positive 11. So we have here positive 12x plus 11, so that the negative 12x and positive 12x will become 0 and negative 11 plus 11 will become 0. So we have here y squared minus 2y is equal to 12x minus 11. The next thing we should do is to complete the trinomial or the perfect trinomial here, y squared minus 2y. So therefore, we are going to do completing the square. So to complete the square, we are going to multiply negative 2 times 1/2, that is negative 1, and then we square it, and then that is 1. So therefore, we are going to add 1 to both left side and right side of the equation. So here, y squared minus 2y plus 1 is equal to positive 12x plus 11 plus 1. And then we have here y squared minus 2y plus 1 is equal to 12x plus 12. And then factor both sides. We have y minus 1 is squared is equal to 12 times x plus 1. So the standard equation is y minus y 1 squared is equal to 12x plus 1. Next, we are going to find the vertex of the parabola. So the vertex of the parabola here is HK. And H here is equal to negative 1 while k is equal to positive 1. So therefore, the vertex of the parabola is negative 1, comma 1. Next, after finding the vertex of the parabola, we need to find the focal distance A of the parabola. So the focal distance A of the parabola is 4A is equal to 12. Then multiply 1/4 to the both side of the equation. Then 1/4 times 4A is equal to A, and 12 times 1/4 is 3. Therefore, the focal distance of the parabola is equal to 3. After that, we need to find the focus of the parabola. The focus of the parabola that opens to the right is equal to h plus a, comma, k. So the focus of the parabola that opens to the right is h plus k, comma, k. So our h here is negative 1 plus a, 3, comma, 1. So the focus of the parabola is 2, comma, 1. Next, we need to find the length of the latus rectum and the endpoints of the latus rectum. So the length of latus rectum is 4a. For a, our a is equal to 3, so therefore 4 times 3 is equal to 12. So the length of latus rectum is 12. For the endpoints of the latus rectum, we need to find the value of 2a. So 2a is equal to 2 times 3 is equal to 6. The endpoints of latus rectum of the parabola that opens to the right is h plus a, k plus 2a, and h plus a, k minus 2a. So we have here h plus a is 2, and then k is 1 plus 2a, which is 6, and then 2, 1 minus 6. So therefore, the endpoints of the latus rectum is 2, 7, and 2, negative 5. And then the axis of symmetry of the parabola that opens to the right is y is equal to k. Our k here is 1, so therefore the axis of symmetry is y is equal to 1. And the directrix of the parabola that opens to the right is equal to x is equal to h minus a. So our h here is equal to negative 1, and our a here is 3. So we have here negative 1 minus 3, then we have negative 4. So our line of directrix is x is equal to negative 4. After that, we are going to graph the parabola. So first, we need to plot the vertex of the parabola, which is negative 1, 1. So here, negative 1, positive 1. So here is the vertex of the parabola. Negative 1, comma 1. And then, we need to plot the focus of the parabola. So the focus of the parabola is 2, 1. So here, 2, 1. And then the line of directrix is x is equal to negative 4. So here is the line of directrix. And then we need to plot the axis of symmetry. Our axis of symmetry is y is equal to 1. So axis of symmetry is y is equal to 1. And then we need to plot the endpoints of the latus rectum. So our latus rectum here is 2, 7 and 2, -5. And in order for us to complete the parabola, we just need to connect the vertex and each endpoint of the latus rectum. So this is the graph of the parabola that has an equation of y squared minus 2y minus 12x minus 11 is equal to 0. For our last example, determine the vertex, axis of symmetry, focus, focal distance A, length and endpoints of the latus rectum of the parabola 2x squared plus 8x plus 32y minus 24 is equal to 0. Then graph the parabola. So we have here 2x squared plus 8x plus 32y minus 24 is equal to 0. So as you notice, the parabola here, the variable x here is being squared. Therefore, this parabola either opens upward or downward. So first, we need to divide the equation by 2 so that the coefficient of x squared here will become 1. So 2x squared divided by 2 is x squared. 8x divided by 2 is 4x. 32y divided by 2 is 16y. Negative 24 divided by 2 is negative 12 is equal to 0. Next, we need to add the additive inverse of positive 16y and negative 12 here. So x squared plus 4x plus 16y, the additive inverse of positive 16y is negative 16y. And the additive inverse of negative 12 is positive 12. So we have here negative 16y plus 12. Then the positive 16y here and negative 16y here will become 0. And the negative 12 and positive 12 here will become 0. So we have x squared plus 4x is equal to negative 16y plus 12. After that, we need to complete the trinomial here through completing the square. So we have 4 times 1/2, which is equal to 2. Then we square that 2, which is equal to 4. So we have here x squared plus 4x plus 4 is equal to negative 16y plus 12 plus 4. Then we have x squared plus 4x plus 4 is equal to negative 16y plus 16. And then we factor both sides of the equation. So we have x plus 2 squared is equal to negative 16y minus 1. So, as you notice, the x variable here is being squared. So, therefore, this parabola either opens upward or downward. But since we have here negative 16, this parabola opens downward. So next, we are going to get the vertex of the parabola. So the vertex of the parabola is h comma k. Our h here is the opposite of positive 2, negative 2. And k here, the opposite or the negate of negative 1 is positive 1. So our vertex is negative 2, comma, positive 1. Next, we need to get the focus of the parabola. The focus of the parabola that opens downward is hk minus k. So here, our h is negative 2, our k is 1. So we need to get the value of a, which is our focal distance. So our focal distance is negative 4a is equal to negative 16, and then we multiply negative 1/4 to both sides of the equation. Then we have a is equal to 4. So our focal distance is equal to 4. So the value of a here is equal to 4. So back to the focus, k minus a is 1 minus 4. So our focus is negative 2, comma, negative 3. Then after that, we need to get the length of the latus rectum. So the length of the latus rectum here is equal to 4a, and that is 4 times 4 is 16. And in order for us to get the endpoints of the latus rectum, we need to get the value of 2a. And our 2a here is 2 times 4 is equal to 8. The endpoints of latus rectum of the parabola that opens downward is h plus 2a, comma, k minus a, and h minus 2a, comma, k minus a. So we have here h, which is negative 2 plus 2a, which is 8, comma, our k minus a is negative 3, and then negative 2 minus 8, comma, negative 3. So the endpoints of latus rectum is 6, comma, negative 3, and negative 10, comma, negative 3. And the line of directrix of the parabola that opens downward is equal to k is equal to k plus a. So therefore our line of directrix is y is equal to k, which is 1, plus a, which is 4. Then we have y is equal to 5. And for our axis of symmetry, the axis of symmetry of the parabola that opens downward is x is equal to h. Our h here is negative 2. So therefore, the axis of symmetry is x is equal to negative 2. Then next, we are going to graph the parabola. First, we need to plot the vertex of the parabola, which is negative 2, comma, 1. So we have here negative 2, comma, 1. And then we need to plot the focus of the parabola, which is negative 2, comma, negative 3. So negative 2, comma, negative 3. So this is the vertex, negative 2, comma, 1. And this is the focus, negative 2, negative 3. Then after that, we need to plot the directrix of the parabola, which is y is equal to 5. So this is the directrix of the parabola. Y is equal to 5. And then the axis of symmetry, x is equal to negative 2. So the axis of symmetry x is equal to negative 2. Then we plot the endpoints of the latus rectum of the parabola, which is 6, negative 3 and negative 10, negative 3. So we have 6, negative 3 and negative 10, negative 3. Then after that, in order for us to complete the graph of the parabola, we just need to connect the vertex of the parabola to the endpoint of the directrix of the parabola. So this is the graph of the parabola that has an equation of 2x squared plus 8x plus 32y minus 24 is equal to 0. So that's all for the parabola, our topic parabola.